Now we look at the types of support in an equilibrium system. First is the fixed support. Consider a wall and a beam fixed at it. Now, for our analysis, we need to understand which are the different types of motions that or the forces that this wall or fixed support will implement or will have a reactional effect on this beam. The first one is the horizontal force that is given by Fx. The other force is the vertical force because it is blocking the movement of the beam in vertical and in horizontal direction. Also, there will be a moment about this point. If the rod is named as AB, then this moment will be MA, and this will be something like this. And these forces will be equated to zero. The next is the hinged support. A hinged support will allow the movement of this beam in, you know, in rotational motion. It will allow the rotational motion. It will allow the circular motion, but it will not allow the motion in x direction, positive x axis direction and positive y axis direction. So, when we take the reaction of this hinge support, we only take Fx and Fy and not the moment as we are taking for the fixed support. In this series, the next one is the roller support. Suppose we have a roller something like this. So this roller can allows the it allows the beam to move in x uh, axis direction. It can move to this direction and also to this direction. It will also allow the rotatory motion, the rotation motion of this beam, but it will not allow the motion in vertical direction. So the reaction of this is only given by summation of force in y direction, because this is the only direction where it is blocking the motion of this beam. The next one is the cable support. Suppose we have a beam something like this, it is fixed here, and at this end it is attached to a cable. This is a fixed support, this we have seen earlier, but for this support by a cable or any short distance support applied at the other end, it is given something like this. Only a force acting in this direction, Fc. Suppose if it is a cable, it is Fc. There is no other thing. For here, for this end, we have all three supports. This is Fx, this is Fy, and since this is a fixed support, we also take the moment into account. Now, I should say, three very interesting cases we have. Suppose we have a smooth surface here, and we have a beam which is, you know, connected something like this to the surface. It is not connected; it is lying on the surface. If it is a smooth surface, for the case of smooth surface, there will be only one force acting on this beam. Suppose we take beam, only one force which will be in vertical direction and given by F1. But if we have the rough surface, suppose this surface is something like this and our beam is kept here, then for the beam there will be an upward force and there will be some friction offered when this beam is moved along the surface. So that is given by Fr and this is Fy. It's very interesting to understand and apply the knowledge. If it is given that we have the smooth surface, we take only one force into account. But if we have a rough surface, there will be some friction while dragging that beam. So we take the frictional force Fr also into account. We have another chapter on friction. We'll study it in detail at that point. The last one is the knife edge. Suppose this is some support or some surface we have and our beam is lying something like this. So for this beam, suppose it's AB and this is point C. So the reaction at this point C is directly taken as this. And this is the reactional force which is acting by this surface and it is at a point and hence this kind of a system is known as knife edge support or a pinpoint support. Before we go on and start solving the sums, it is very important to understand that we can have a very big system given to us. To solve sums, we need to learn a new concept that is called FBD, which is free body diagram. What we do here is we just take only a portion of system where we need to find the forces, and for the other portions we just take the reactional forces. We'll take an example here. Suppose we have Salman Khan sitting here with with three books on his head and he's sitting on a table. If we draw FBD of Salman Khan, we will just draw Salman here and at this end he's sitting on a table, so he's exerting a force on the table and the table will exert some reactional force on Salman. So that force is taken here. So this is force of which is acted by table. So suppose we take it as Ft. And if there are three books on Salman's head, these books will put a pressure in the downward direction. So this will be suppose Fb in the downward direction. So this is how we will represent Salman Khan and solve for the condition of equilibrium. If this system is in equilibrium, we'll not have any other table or book or any other component in this FBD. This is a free body diagram of Salman Khan. Now, suppose for the same case, we draw an FBD for table. So we'll draw the table. There was Salman Khan was sitting. We'll exert some force on this table. So this will be Fs. There was also some books on Salman's head, which will also be acting at this point. So this will be Fb, and both these forces combined, if they are in a same line, there will be a combined action of these forces on the table. So what we'll get is a table with a force Fb plus Fs on the same point. So this is very important to know how to draw an FBD because this will help us in solving sums. अभी 3 sum